Why is cache and why does it exist? The problem people are facing. Let me paint picture you already know. Imagine you open your favorite app, you tap on your profile and then you wait. The little spinner spins 1 second, 2 seconds, 3. You are staring at a loading circle and honestly you are already annoyed. Now multiply that feeling by a million users. That's the nightmare every backend engineer wakes up sweating about. Here is what actually happening behind that spinner. Every time someone asks for data, the app runs to the database and says, hey, give me this user profile. The database goes digging through its files on the slow disk, find the answer and send it back. That trip takes time, not a lot, maybe a few milliseconds, but it's add up fast. Now here is a painful part. Think about your app's homepage. The same trending post, the same top product, the same profile picture. Thousands of people ask for the exact same thing again and again and again. And every single time your poor database does the same heavy work from scratch. It's like a librarian who every time someone asks for a most popular book in the building, walk all the way to the basement archive to fetch it, and even though 100 people ask for that same book in the last hour, the database gets tired, it gets slow, it gets overwhelmed, your app crawls, your users leave, and you, the engineer, are paying for the huge expensive server just to answer the same question over and over. That's the problem. We are doing expensive repeated work for answers that barely change. How the idea of caching solves it? So one day someone smart asked a beautiful question. If the answer is the same every time, why are we calculating it every time? Why don't we just remember it? That's caching in one sentence. A cache is a small, super fast place where you keep copies of answers you have already worked hard to get. So the next time someone asks, you hand it over instantly instead of doing all that work again. Go back to our library. Instead of running to the basement every single time, she keeps the 10 most requested book right on her desk. Someone asks for the popular book, she just turns around and grab it. 2 seconds becomes 2 milliseconds. The basement, the database gets a break. Everybody is happy. The desk full of popular books, that's a cache. You already use caching in real life without naming it. The snacks you keep on your kitchen counter instead of in the garage. The phone numbers you have memorized instead of looking up. The route to work you don't need a Google map for anymore. All of these are caches, keeping frequently needed things close and fast. Now what exactly is cache? Let's make this concrete. A cache is a storage layer, usually living in a fast memory RAM that sits between whoever is asking for data and the slow place where the data really lives, like a database or another service. It stores data as a simple key value pair. The key is the question and value is the answer. For example, key user 42 profile value. When a request comes in, the app doesn't run straight to the database anymore. It first asks the cache, do you already have the answer for this key? If yes, we call that cache hit. The cache hand it back instantly and done. If no, we call that cache miss. Now the app goes to the database, get the answer, and this is the clever part. Store a copy in the cache on the way back so that next time it's a hit. That's the whole heart of it. Check the fast place first. Only do the slow work when you absolutely have to. The reason this is so powerful comes down to one simple fact about computers. Reading from memory, that is RAM, is roughly 1 lakh times faster than reading from a spinning disk and still way faster than a database query that has to do work. A cache lives in that fast memory, so a cache hit can be a fraction of millisecond while the full database strip might be many milliseconds. That gap is the entire reason cache exists. Now why use it? 3 big wins and they all matter. It makes things fast. This is the obvious one. User feels speed. A page that loads instantly feels like a magic. A page that hangs feels broken. Speed is not a luxury. It directly affects whether people stay or not. It takes load off your database. This is the underrated one. Every request the cache answer is the request your database didn't have to handle. If 90% requests are hit, your database is suddenly doing 10x less work. That same database can now serve 10x more users without breaking a sweat. It saves money. Faster responses with less work means you need fewer big expensive server. A small cache box can absorb the traffic that would otherwise force you to buy 5 more database machines. Speed, scale, saving, all from the simple act of remembering how to use it. Let's walk through the actual flow step by step, like watching it happen. A request comes in, give me user 42 profile. The application first look in the cache for the key user 42 profile. Cache miss. First time nothing stored yet. So the app goes to the database, runs the query, gets the profile. On the way back to the server, the app writes a key into the cache. User 42 profile data. The user gets their profile. Slightly slow this one time. That's fine. Now a second request comes in for the same user 42 profile. The app looks in the cache for user 42 profile. Cache hit. The answer is right there in the fast memory. The app returns it immediately. No database trip at all. That's it. The first request warms up the cache and the everyone after writes for free. A couple of important details that make this real. Cache don't keep things forever. Memory is small and expensive, so a cache only holds a limited amount. We attach a TTL, that is time to live, to entries. Basically an expiry timer. Keep this for 60 seconds, then forget it. When data expires, the next request becomes a miss again and refreshes the copy. This keeps the cache from holding ancient wrong data. When the cache fills up, it has to throw something out to make a room for new stuff. The rule it uses to decide what to throw out is called as the eviction policy. The most common one keeps the recently used item and drops the ones nobody asked for in a while. We will go deep on that in a later topic. For now, just hold this mental model. The fast box in front of the slow box. Check fast box first, fill it as you go, let things expire so they stay fresh. Trade-offs of using it. Caching feels like a free magic, but nothing is free. Here is a honest cost. Stale data. This is the big one. The cache holds a copy. If the real data in the database changes, but the cache still has the old copy, users see outdated information. Someone updates their profile photo, but for the next 60 seconds, the cache still shows the old one. For a profile photo, who cares? For a bank balance, that's a serious problem. Deciding when a copy is too old is genuinely one of the hardest things in this whole field. Other trade-off is moving parts. More moving parts. You have now added another system to run, monitor and pay for. More things that can break. If the cache itself goes down, suddenly all the traffic slams your database at once and the database that got comfortable doing 10% of the work can fall over. Next trade-off is complexity in your code. Your app now has to handle hits, misses, expiry and the awkward in-between moment. It's more logic to get right. So the trade is simple to state. You trade perfect freshness and simplicity for speed and scale. Most of the time that's a great deal. Sometimes it's a terrible one. Knowing the difference is the skill. Now when to use it? Reach for cache when the same data is read far more often than it changes. Trending post, product catalog, configuration settings, user profiles, read heavy, write light, that is the sweet spot. The data is expensive to compute or fetch. A heavy database query, a slow calculation, a call to a slow external service. If the work is costly and the answer repeats, cache it. A slightly old answer is perfectly acceptable. A like count, a view count, a trending now list. Nobody is harmed if it's a few seconds behind. You are getting harmed by traffic on a few popular items. The classic hot data problem, a handful of items everyone wants. Now when not to use it? Skip the cache or be very careful when the data changes constantly. If it's updated every seconds, you will spend all your effort refreshing the cache and almost never get a useful hit. You added complexity for nothing. Every answer is unique. If no two requests ask for the same thing, there is nothing to reuse. A cache full of one-time answers is just wasted memory. Stale data is dangerous. Money, inventory, count at checkout. medical info, security permission, when showing an old value could actually hurt someone or cause a real bug. Don't gamble on copy. The data is already fast to get. If your database returns it in well under a millisecond anyway, adding a cache buys you nothing and costs you complexity. The golden rule: cache things that are read a lot, change a little, and don't hurt anyone if they are slightly stale. Now the common mistakes. A few traps that catch almost every engineer. Caching everything. New engineers discover caching and want to cache the whole world, but caching rarely reads or constantly changing data but waste memories and create stale data bugs. Cache with intention, not by reflex. Next is forgetting to set an expiry. They store data with no TTL and it lives forever. Months later, users are seeing data that's hopelessly out of date and nobody knows why. Always think about how long a copy stays valid. Next is treating the cache as a source of truth. The cache is a copy. It can be wiped, it can be crashed, it can expire at any moment. Your real data must always live safely in the database. If your app breaks when the cache empties, you have designed it wrong. Next is ignoring the what if the cache dies question. If your cache disappears and all traffic floods the database instantly, can your database survive that? If you have never asked this, you have a hidden time bomb. Next is caching personal data under a shard key. Accidentally serving one user's private data to another because the key wasn't specific enough. Always make key specific. User 42 profile, not just profile. Now few of the famous interview questions. Be ready to answer this clearly. What is cache and why do we use it? What's the difference between a cache hit and a cache miss? Where does a cache physically live and why is it so fast? What is the stale data and how would you handle it? What happens to your system if the cache goes down? Would you cache data that change every second? Why or why not? How do you decide what to cache? Here are 3 things to walk away with. A cache is a small, fast memory layer that stores copies of answers you have already worked for. So the next time someone asks, you hand it back instantly instead of redoing slow work. Second, it exists for 3 reasons: speed, taking load off your database, and saving money. Third, the price you pay is the stale data and extra complexity. So cache things that are read often, change rarely, and don't hurt anyone if they are little out of date. Remember the librarian with the popular books on her desk. That's caching. Everything else in this module is just a details of how to keep that desk organized.